Dear students, in this video lecture, we'll try to study what you mean by angle stability assessment. We know that the transient stability studies of a typical 500 bus and 100 machine system, generally it requires around 1 hour of run time whenever we are talking about the simulation. Even only if I take for a single contingency. Therefore, generally the direct methods of stability assessment such as Lyapunov or energy functions are the attractive alternatives for this particular situation. It should be noted that transient stability study is one of the investigation whether the synchronous generators following the occurrence of disturbances that will remain in synchronism so that general purpose transient analysis to investigate the quality of the dynamic system behavior or not. So this we are going to study in detail. Usually the transient period of the primary interest is the electromechanical transient, usually lasting up to a few seconds of a duration. If the growing oscillations or the behavior of special controls are a concern, the study may involve a longer transient period also. So the figure shows the overview methods for angle stability. This is as clearly mentioned. There are three methods. One is the direct method, another one is the indirect method, third one is the new methods. So in case of direct method, as I just discussed, you can go for energy functions, you can go for Lyapunov methods, or you can go for EQSC method. In case of indirect method, you can go for RK4, you can go for EM method, you can go for trapezoidal method. In case of new methods, you can go for adaptive dynamic control ADP method or expert system, or you can go for artificial neural networks, you can go for the fuzzy logic, or you can go for the genetic algorithm. So actually what happens here is in actual system of operation, the parameter and the loading conditions are different from the assumptions whatever we made during the planning stage. So as a result, to ensure the power system to the security against the possible abnormal conditions due to the contingencies, the system operator needs to simulate the contingencies in advance, and he has to assess the results and take the preventive control action if required. So for that we are going to study these things. Then to solve the time domain stability problem, usually the numerical methods are utilized based on the predictive and corrective methods, and to provide the suggestions for the further interpretation which includes these methods. Usually what happens to solve the particular method, these following methods are used. Especially one is the numerical method. In case of a numerical method, the Euler approach converts the differential equations from digital to analog, and these numerical methods will solve the numerical techniques by analyzing the decoupled first and second order state differential equations with the predictor and corrective technique. These methods are used today, and they lack characteristics such as the robustness, scalability, stochasticity, predictivity, and adaptability of the future grid, which is completely absent in the current power system operation. Especially in the second method, that is artificial intelligence method, this technique usually uses the computational intelligence to estimate the stability margin and the computational indices. This method includes some of the expert system for classifying the contingencies, and it will also used for identifying and estimating the instability margins. Usually the neural network is also used as a classifier for different stability margins based on the network features and the parameters contributing to the estimation of the instabilities. So other artificial intelligence methods also used such as the genetic algorithm method. These methods are used to model the usually the inherent stochastic elements of the network. The important technique for stability assessment includes usually the dynamic security assessment method, which is used from the last several years. The third one is the evaluation of dynamic security assessment and its potential for real-time stability in a smart grid environment. Now let us study what you mean by the transient stability. So consider an autonomous system described by the ordinary differential equation, which is represented as x is equal to f of x, where x is equal to x of t and f of x are the n number of vectors. F of x is generally a non-linear function of x. So the stability in the sense of the above equation is referred as the equilibrium state. The equilibrium state is defined as the state of x at which x of t remains unchanged. So in this case also the transient stability can be analyzed by taking the suitable equations. Then let us study what you mean by the stability application to a practical power system. Since the application of the direct methods to the actual power system is very difficult, so it becomes necessary to make the number of simplifying assumptions. So up to the date, the analysis has been mostly limited to the power system representation with the generators represented by some of the classical models, and loads are modeled as constant impedances. Recently, several attempts to extend the method, those includes more detailed load models as explained already. Let us study the flowchart of the TF method, whatever we use for the transient stability analysis. Again the same here, we are taking the input data, then we are doing the power flow calculations. After that we are doing the contingency specifications we are measuring. Then we are forming what is the fault matrix, Y matrix and reduced Y matrix. We are doing the post fault Y matrix also we are defining. After that we are calculating the post fault state estimation. Then we are calculating the critical energy. After that we are calculating the system total energy. Then we are checking whether the critical energy is greater than the estimated or not. If it is no, then it is unstable. If it is yes, it is a stable, then we are going to stop the condition. So here VCR and VCL, next one is both are compared. If the VCR is greater than VCL, if the VCR is greater than the VCL, then it shows that the particular system is stable. If the VCR is less than VCL, then it is unstable, then it will stop the calculation at that particular point. So this is what the model, what the point I am going to discuss in this particular video lecture. So in the next video lecture, we will talk about the state estimation part. Thank you.